Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Dutch Flatmates Parity. It's a tessellation by Flinty. And here are the tessellation rules. Or here are the rules. We have tessellation rules, where we need to place a digit from 1 through 9 in each square and octagonal cell. And cells sharing an edge can't have the same digit. So for example, whatever digit is here, say it was like a 6, you could not have a 6 in any of the cells that share an edge with it. Same with the squares, but squares are only 4 cells that are next to it. And each horizontal row and vertical column contains a non-repeating consecutive set of digits in any order. So this is basically a Renban-like rule, where you have to have, essentially, in every row and every column, you must form a set of consecutive non-repeating digits. So you could have something like, say, 2, 6, 4, 3, and 5, and this would be valid because 2 through 6 forms a set of consecutive non-repeating digits. And that's the tessellation rules. We also have flatmates, where every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So in every 5 in the grid, you have to have a 1 directly above it and a 9 or a 9 directly below it. And finally, we have parity lines, where adjacent digits along a red line must have different parities. So basically, this is a different parity than this, which is a different parity than this, which is a different parity than this. So it alternates, right? Because so if this was, say, a 3 or an odd digit, this would have to be even. Say we had an 8, and then this would have to be odd, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, what we know is... So we know in rows 3 and 7 and columns 3 and 7, you are guaranteed a 5. Actually, we know that for rows 3 through 7, you are guaranteed a 5 in all of those rows, and you're guaranteed a 3 through 7 in columns 3 through 7, you are guaranteed a 5. So we know we have at least 5 5s in this puzzle. So for every column, you're guaranteed to have either 1 through 5 for the 5 cells, or 5 through 9. For the 7 columns, you're guaranteed to have 1 through 7 or 3 through 9, because you have to have a 5 in each of those columns, and they must have a 1 above it or a 9 below it. Right? If you have a 1 above it, that means the 5 digits you have are 1 through 5. If you have a 9 below it, that means the 5 digits you have are 5. So because of that, we know in each of those columns, you have 3 odd digits and 2 even digits. Right? 1 through 5, 1, 3, and 5 are odd, 2 and 4 are even. 5 through 9, 5, 7, 9 are odd, and 6 and 8 are even. In column 7, we have guaranteed 3 cells which are the same parity. So therefore, those must be the odd ones. So 5 has to be one of those 3. So it's either 1 through 5, and these are even then. That means, yeah. So odd. So this is, we're going to make these different sets. So this is pink, yellow, pink, yellow, pink, and yellow. Okay. Therefore, these must be even here. So this is 2, 4, 6, or 8 here, right? This has to be 5 with a 1 above it. So you would have 5 with 1 above it. Or obviously 3 can work. Or 5 with 9 below it. And then 7 could be any of the others. 7 cannot be the middle. 3 and 7 cannot be the middle. Because if 3 is in the middle, that means 5 will not have a 1 above it. And 5 will not have a 9 below it because these are both even, right? So this is 1, 5, or 9. You could have 1 here, 5 here, and 3 here. Or 1 here, 5 here, and 3 here. These are even. So 5 cannot be any of these. These are different sets. So we're going to make this dark and this medium. Medium, dark, medium. Therefore, these are different sets. These are different sets. We need a 5 somewhere with a 1 above it or a 9 below it. None of these can fulfill that. Therefore, this must be a 5, and this must be a 1 above it. So this is 2 through 7. So this is 2, 4, 6, 2, 4, 6. One of these is 2, 4, 6, so this must be 3 or 7 here. So this is 5. This must be 1 through 5 here, then. So this cannot be 6 or 8. So this has to be 1, 3, 5, and this is 2 or 4. This is even. Because this is odd. And this must be odd, so this is 3 or 7 to be with it. This has to be even. So it's 4 or 6. This has to be 1 through 5 here. 2, 3, 4, 5. 5 cannot be here. One of these is guaranteed to be 3, so since one of these is guaranteed to be 3, this can't be 3. That's 7, which forces this to be 6. So 5 is one of these two. 5 cannot have a 9 below it, so one of these is 1. So this must be 1 through 7 here. 2, 3, 4, 5, 6, 7. No 6 here. 1 through, no 7. 1 through 7. No 1 here. 2 through 7 here. Okay. So 1 has to be one of these two. That doesn't tell us much. This could be 5 if this is 5. So this is 2 or 4. That means this is 8, up to 8 at most. So it's 1 through 8. Obviously, this can't be 6. Five. Okay, this cannot be 5 through 9. If this is 5 through 9, the problem is this digit cannot be... It would have to be 5, but then that would require a 1 above it. So this has to be 1 through 5. Which means this is 1 through 5. Since this is 1 through 5, it still could be up to 8 here. So we're guaranteed a 4 here and a 5 here. So 4 could obviously be any of these. 5 has to be... A 4 could even be here. 5 would have to be one of these 3. Whatever digit's here has to be here for this column. So this has to be 2 or 4. Because it basically shares an edge with all of these. So whichever one is here cannot be any of these. Oh, no, we knew this is 1, so that limits things a lot. This obviously cannot be 7. Both of these are 5. So this cannot be 5 here. One of these is 3, so this can't be 3 there. That's interesting. One of these is 1. So this can never be 3 either. Because if that's 3, this would have to be a 1, but then that would be a 3. They would have to be different parities, which doesn't work. So this can't be 5 either. If this is 5, this would have to be 1. And you have the same problem. So the 5 in this column... Okay, so 5 cannot be any of these cells. Because they're different sets, right? 5 has to have a 1 above it. Oh, 5 could be here. 5 cannot be here, though. So this can't be 1, then, because if this were 1, the problem... Okay, it can't be 1 because one of these two is 1 anyways. But if this is 5, this would have to be 1. If this is 5, that would have to be 1, so this can't be 1 either. So if this is 5, this is 1. If this is 5, that's 1. So therefore, the pink must be odd digits. So these are all odd. So this is a 1 here. So this is 1, this is 5, and that's 3. And these must be even. Yellow must be even. So this is even also. And it has to be 2 or 4. So this is 2 or 4, this is 2 or 4. That means this must be 2 through 6 or 1 through 5. So no 7 or 8. And no 2 through 4 in the remaining digits. You can only have one other even, so these must be odd then. So these must be odd, which makes these even. So this is not 3 or 7, it's 2, 4, 6. This can't be 1. We have all the evens in row 6 now. So the rest must be odd. So this is odd, this is odd. You cannot have 2, 3, or 4 here. 3 eliminates 3 here. This can't be 5, therefore the 1 must be above the 5. 1 is here, 5 is here, 3 is here. This can't be 3 or 5, it's 7. This can't be 3 or 7, it's 5. That eliminates 5 from being here. That means this has to be 5 here. This is 3, which forces this to be a 1. 5 has to have a 1 above it or a 9 below it. It cannot have a 1 above it because this is a 1, so this is 9. And we have a contradiction. Okay, we messed something up. Let me restart. So again, every column in column 3 and column 7 have to be 1 through 5 or 5 through 9. Right? Because you're guaranteed a 1 above the 5, which you have to have in that column, or a 9 below the 5. And you can't have both. So again, these have to be odd. These must be even. So if it's 1, 3, 5, then, okay, these are even. So it's 2, 4, 6, 8. If these are different let's make it orange and I don't know, orange and yellow here. Orange, yellow. And then we'll make this green and pink. These are the same. We're gonna make these medium and dark. So again, in column 6, we are guaranteed a 5. So we need a 5 with a 9 below it or 5 with... Oh, this doesn't have to be... That's the thing. This is a 5. It could be 5-1 or 5-9 as a combination. Okay. Right, that's where I messed up. So therefore, these are even. These are odd. This has to be odd, odd, because there's no other odd, odd possible in column 6. So one of these is 5. We don't know which. And it looks like it's not 5-1 because we ran into a contradiction there. So these must be even. Yeah, we ran into a contradiction there. So let's just take a look at that again. If we had 5 here and 1 here, then this has to be 1 through 5 here. This would then be 2 through 4, which means this is 1 through 5. So 1 would have to be either here with 5 below it, and that's 3, or 1 would be here with 5 below it, and that's 3. And those are the possibilities. This is 2 through 5 here. Obviously, 5 can't be here. 5 would require one of these to be 5, so 1 would have to be one of those two. Because 1 is one of those two, it would this could not be 3. So this would have to be 7, which makes this 5, 6, 7. We don't know what this is. This is some even. 3 is one of these. 5 is one of these two, which means it cannot have a 9 below it. It must have a 1 above it. So this must be 1 through 7 here. We need a 5. Okay, so this is the same problem, right? We don't have to do that yet then. So these are even. We need both of these to be the same. Obviously, 5 can't be here. 5 can't be here. 5 could be either here, here, or here. If 5 is here, that's 1. If 5 is here, that's 1. If 5 is here, that's a 9. So either way, green has to be odd, and pink has to be blue. And the reason why then, this would have, if this is 5 here and 1 here, that means this has to be 2, 3, 4, 5. 1, 2, 3, 4, 5 here. So this can only be 2, 3, 4, 5. You can't have 5 be here and this be a 5 through 9 because you need a 1 above it or a 9 below it, and you can't have the 9 below it. So this must be 5, 1, 3, 2 and 4, 2 and 4. And then we come to the contradiction, right? This is 2, 4, 6. This can't be 3, that's 1. This is 5, that's 3. Therefore, this can't be 3 or 5, that's 7, which forces this to be 5. What was the contradiction again? I don't remember. This was 7. Oh yeah, this was the contradiction. We had to have a 5 somewhere here, and that meant it had to be here. This cannot have a 1 above it. It cannot have a 9 below it. Wait, why didn't this work? I don't know. This is even. So this would be 2, 4, 2, 4. This would have to be 1 and 3, so this would be 3. This would be 1. Okay. This would be 2 or 3 or 4, 2, 3 or 4. 2, 4, 6, 2, 4, 6, 2, 4, 6. Why couldn't this be 9? Huh. Obviously, this couldn't be 2 anymore. So no 2, no 2. This had to be even, so it'd be 4, 6, or 8. This would have to be 2 through 7, 2, 4, 6. This would be 2, 4, 6. And this would be 7. Wait, this works. Why did I say that it didn't? I don't know. This is odd. 8, 7, 6 works. 6, 4, 5 does not work. 2, 3, 4 does work. Oh, this was a contradiction. We had a 9 and a 1 here in this row. And that's the contradiction. So now we know this can't be 5. Because of that. So this has to be 5 here, and this is 9. So then this is 3 through 7. So this has to be 9 and 7 here, which forces this to be 8. This is 5. We don't know if it goes either way. It could go either... Oh, none of these can be 7. So since none of these can be 7... That means this is 2 through 6 or 1 through 5 here. Okay. 5 cannot be here. So therefore this must be 5 and 9. Actually, no. 5 could be either of these. So this would be 5. So if this would then be odd. You could have 5 here with 9 being there, or 5 here with 1 being there. Therefore, these are odd. These must be even. So this is 2, 4, and 6. This would have to be 8 if this is... Because we know this is... Okay, so this is guaranteed to have a 3 here. Because this must be either... It cannot contain 7. And it must be 2 through 6 or 1 through 5. Therefore, if this is 5 through 9, this is 8, or this is 2, 4. If this is 1 through 5, this is either 3 or 7 here. We're not sure which. So if this is 5 through 9, this must be 8. These are even. Where's the 5 in column 4? Can't be here because it can't have a 1 above or 9 below. Can't be here. It could be any of these 3. With a 5 being here. Okay, so if this is 5, that would force this to be 9. To be below it, because these are opposite sets of parity. So that 5 would force this to be 1. This 9 would force... Okay, that works. Okay, so... If this is 5... Okay, so if this is 5, you could have 9 below, 1 above. Let's see. One of these 3, one of these 2 is even. This is even, that's even. These are both odd. So to get 3 through 9, you have to have 4 odd, so this must be odd. One of these is odd. You could have the other one be even. So this is 1, 2, 3, 4, or 6, with 3 being one of those 2. 5 has to have a 1 above it or a 9 below it. This is 2, 4, or 6. This is 4, 6, or 8. 4, 6, or 8. And one of these is 4, 6, or 8. This then is 3 or 7. We don't know what these are. These are 3, 4, 5, 6, 3, 4, 6, 7, 8. Okay. We are guaranteed a 4 in one of these. We're guaranteed 3 through 6 in... Sorry, 3 through 6 in the rest of column 4. But that doesn't tell us too much. Again, what are these possibilities? You could have 1 here, 5 here, and 3 here. Or 1 here, 5 here, and 3 here. You could have 5 here, 9 here, and 7 here. Or 5 here, 9 here, and 7 here. If 5 were here, the problem is that would eliminate 5 from both of these cells, and therefore this wouldn't be a full Renban. So this cannot be 5. So if 5 is here, this is 9. If 5 is here, this is 1. So this is guaranteed to be 1 or 9. Well, as 1 or 9, the problem is that you cannot have 9 here, which would force that to be 1, because this is only 7 in length. So, this is guaranteed to not be... You cannot have 9 here, so this must be 5, which makes this a 1. Therefore, that makes this 9. So this cannot be 1 here. It cannot be 5. It's 3 or 7. So this must be 1 and 5, or 5 and 9. Also... No 8, no 6. This is 2 or 4 here. That means this is 3. This cannot be 1 or 2. This cannot be... This is 9 here, so this cannot... This has to be 4, 6, or 8. We need to have a 5 above it. Or 5 specifically has to have a 9 below it, so those are odd. These are even. This is a 5. This must be 1, 2, and 4. So this must be 2 and 4 also. So we have a 2, 4, 2, 4 pair in row 7. This must be 5 and 1 and 3 to make a 1 through 5 Renban. Since this is 1 and 5, this must be odd. So it must be 3, which makes this even, and it's 2 or 4. This 3 eliminates 3 here. So this is 7. No 3 or 7 here. This 2-4 pair sees both of these cells, so these cannot be 4. This becomes a 6-8 pair, which eliminates 6 and 8 in the rest of the column, so this is 4, which means this can't be 4. This is 6 or 8. 4 eliminates 4 here, so this is 2, which means this can't be 2. That's 4, which means this can't be 4. That's 2. That eliminates 2 in the rest of the column. This is either to be with 6 or 8. It's 5, 7, or 9 here. This has to be 4, 6, or 8 here. This cannot be 5. Okay. What are the possibilities here? It's 2, 6. This 2 eliminates 2 here. So this is 4. So this is 2, 6, or 8 here. We need a 7 in one of these spots. We don't know which. This has to be 3, 5, or 9. This can't... It could be 6. This is 3 through 9 here. So we have 4, 6, 7, 8. 4, 6, 7, 8, and 4, 6, 7, 8. This can't be 4 because it's neighboring a 4. This can't be 8 because it has an 8 there. Six, 7, 8 either must be 4, 5, 6. So it could be 4. It can't be 4 here. Can't be 4, 5, 6. 5, 6, 7. So 5, 6, 7 works. 6, 7, 8, which would be 6, 8 and 6, 7, 8 here, or 7, 8, 9. So 7, 8, 7, 8, 9 are possibilities. Okay. 2, 3, 4 works. We don't know which one that is. Remaining digits in row 6 could be 1 through 1, 2, 6, 7, 8, 9. No 2 or 8, obviously. That's fine. Remaining digits in column 4 are 3, 4, 6, 8. Okay. We have to have a 5 somewhere. If this is 5, this can't be 5, because if this were 5, this would have to have a 9 below it. And then it would be 9, 8, and 8 for 2 evens. So this can never be 5. So 5 could be here with a 1 above it. 5 could be here with a 9 below it. Oh, this can't be 5 on this 3-length rim band. If you have a 5 on the 3-length rim band, it has to have a 1 above it or a 9 below it, and that's not possible. So 5 can't be here, 5 can't be here, 5 can't be on these cells because they don't have a 1 above it or a 9 below it. Where's the 5 in row 5? It has to be here. So this is 5, which makes this 9. That eliminates 9 here. This can't be 2. This is a 6, 8 pair, which eliminates 6 and 8 here. So this is 7. This is an odd. We have odds here. This can't be 5 or 9. It's 7. So that's between 6 and 8. We have a 6, 8 pair in column 4, which eliminates 6 and 8 in the rest of the column. So this can't be 6. This is 3. This can't be 3. This can't be 7. This can't be 6 or 8 or 3, so this is 4, which eliminates 4 here. That's 2. Actually, we already knew that before. 6 and 8 cannot form a 3-length rim band with 3, so this must be 9, and this must be 8, which makes that 7. So that makes this 6, which means this can't be 6. This is 1. We have a 4, 6 pair in column 5, which eliminates 4 and 6 in the rest of the column. So this can't be 4, 6, it's 3. 6 here eliminates 6 here, so it's 8 and 6, which makes this 8. This can't be 7 or 8, it's 6. That makes this 6, 7, and 8 to form a rim band. 6 eliminates 6 here, so it's 4 and 6. And we're missing just 3 and 6 in row 5. This can't be 6 because of 6 there, and therefore this is a 6. And that's the solution. Yeah, I kind of messed up the first part by making this assumption about the 5s. That was my bad. But actually that helped us go through the possibility where you can't have 5 here and 1 above it, right? Yeah, not too bad. Aside from that bad mistake here. But that, again, as I said, that helped us basically go down that path and see, oh, we have a contradiction, actually, so... And I think we would have had to do that anyways, so it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.